All right, so we've been talking about systems of equations. And in section 1, we talked specifically about solving systems of equations using graphing. So we would graph two lines, and then the part that we would care about is where those two lines cross, where they intersected. So remember, two lines intersect. They intersect when the two equations are equal to each other. In other words, what that means is that the x and the y values are the same in both equations. Your x and y values are going to be the same. So I have the steps written out for you, 1 through 4, of how we solve using substitution. That's what we're going to be talking about today. And substitution is really what it sounds like, right? So if you substitute something for something else, something stands in the place of something else, right? So that's really all we're doing is we're going to substitute something for something else in these equations. So I'm going to walk through each of the steps, and we're just going to do it together, and then you will see what each of those steps means as we do it. So the first thing that we want to do is we want to solve one of our equations for one of the variables. We're lucky in this case that one of our equations is already in that form. So essentially what I want is I want for one of my equations to look like y equals something or x equals something. So my step 1 is already done for me. My y is going to equal 2x minus 9. Here's where the substitution part comes in. Step 2, I'm going to take y equals negative 2x minus 9 and plug it in for y in the second equation. So here's how this looks. We would have 6x minus 5, and then instead of writing y, I'm going to write negative 2x minus 9 equals negative 19. Here's why I can do that, right? An equal sign means that both things are the same, right? So y equals negative 2x minus 9 means that negative 2x minus 9 is the same thing as y, right? So I just swapped it in there instead. So then we're just going to solve this like we normally do. We'll distribute. So I have a 6x plus 10x, because negative 5 times negative 2 is positive 10, plus 45 equals negative 19. I'll combine like terms, so I get 16x plus 45 equals negative 19. We'll subtract 45 from both sides. We get 16x equals negative 19 minus 45 is going to give us a negative 64. Divide both sides by 16. I get that x equals negative 4. That's step 2. So step 1, I want one of my equations to look like y equals something or x equals something. Step 2 is that I'm going to substitute what I get from step 1 into my second equation and solve. When I solve, I'm going to get a value. So the value that I got was that x needs to equal negative 4. So step 3 then, what I'm going to do is I'm going to take this x equals negative 4 and I'm going to plug it back into my original equation to figure out what y needs to equal. So y equals negative 2 times negative 4 minus 9. So y equals negative 2 times negative 4 is a positive 8 minus 9. So y needs to equal negative 1. So now I have the two components I need. So my final step is step number 4, and that's where I list out the solution. So the solution is my x was negative 4, my y was negative 1. My solution is negative 4, negative 1. And I'm going to go ahead and prove it to you. Here we go. We're going to open up, I have Desmos open right here. All right. We're going to put these equations in Desmos, and I'm going to show you what this looks like. So I have y equals negative 2x minus 9, and I have 6x minus 5y equals negative 19. I care about where they cross, and look at that. They cross right here, and negative 4, negative 1. And that was exactly what we came to with our calculations. Okay? Let's look at another one. Example 2. Negative x plus y equals 3, and 3x plus y equals negative 1. So this is going to require us to do another step. So the first step we missed on the one before. So step number 1 is to have a y equals something or an x equals something. So I always like to look for the easiest or most obvious place for me to rearrange my equation. So what that means is I'm looking for, are any of my variables by themselves, right? Because I know that I need to solve for one of them. So if they're by themselves, then that's good. I also like to look for negatives, and here's why. I think that adding is easier than subtracting. And so if I see a negative, that tells me that, well, to solve something, that means I'm going to have to add. So I would probably choose the first equation, negative x plus y equals 3. Because all I need to do to get y by itself is add x to both sides, right? So then I get y equals 3 plus x. That's step number 1. Step number 2 is where I substitute. So I'm going to take 3x plus 3 plus x needs to equal negative 1. Combine these, I get 4x plus 3 equals negative 1. Subtract 3 from both sides, I get 4x equals negative 4. X equals negative 1. That's step 2. Step 3 is I'm going to plug it back into the original equation. So y equals 3 minus 1, y equals 2. Final step is step 4. The solution is negative 1, 2. Here's what I'm going to say about this too, is you may get to a point where you're like, well, I got an answer, but I don't know if it's the right answer. There's a really easy way for us to check to make sure that our answers are correct. So when we are looking at the solution of a system of equations, we talked about how lines only intersect once, right? They intersect at one point. And so if this is the solution, that means that negative 1, 2 is going to work in both equations. It'll make both equations true. So if I look at the first one, I have negative x plus y equals 3. Well, a negative negative 1 is a positive 1 plus 2 sure does equal 3. If I look at the next one, I have negative 1 times 3, negative 3, plus y, which is 2, equals negative 1. That does equal negative 1, right? So I can check to make sure that my solution is correct by just plugging those values back in and seeing if it makes both equations true. All right, let's go ahead and look at the next one. This one is going to seem a little bit less obvious, right? So the other ones we had an x or a y that you could tell was going to be able to be by itself really easily. I don't really have one here that is obvious that I can get it on its own, right? So this is where I would look for negatives. So I would probably choose the first equation because I have a minus 4, and then I would just solve for x. So that's what I'm going to do here. So I've got 3x, and then my first step would be to add 4y to both sides. So I'd have 3x equals negative 1 plus 4x. Next step is just to divide by 3, right? So then I have x equals, I'm going to put my 4/3 first, 4/3 x minus 1/3. And that's the equation I'm using. Step number 2. Okay, I'm going to take my x equals 4/3 x minus 1/3, and plug it into my equation. So I would have 5 times 4/3 x minus 1/3 plus 2y. Oh, I did this wrong the other day too. Hold on. It's not an x, it should be a y. 4/3 y. 4/3 y. There we go. Equals 7. Okay. Now I'm distributing, right? I'm going to take this 5, distribute it here, and over here. When I multiply fractions, I just multiply across. So I would have 20/3y minus 5/3 plus 2y equals 7. All right, now I have to start combining things, right? And I know that when I add fractions, I need to have a common denominator. So I'm going to look at I can combine my 20/3y and I can combine my 2y over here, right? But I need to have a common denominator. So my common denominator is going to be 3. So if I change the bottom to 3, that means this top needs to change to 6. Right? 3 divided by 6 is 2. So now I would have 20/3 plus 6/3. So my new y value is going to be 26/3y minus 5/3 equals 7. Okay? Now I need to do a similar thing here. So I'm going to add 5/3 to both sides. I'm going to make it a little plus 5/3. I need to do the same thing with my 7. So 7/3 is not going to work. It needs to be 21/3. So if I add those two together, what I have down here is 26/3y on this side equals 21 plus 5 is another 26/3. So what that means then is that y equals 1, right? 26/3 times 1 is 26/3. So my y equals 1. Now I can take my y value and plug it in to figure out what x needs to equal. So let's go ahead, I don't know, let's do the top one. 3x minus 4 times 1 needs to equal -1. So 3x minus 4 equals -1. I'm going to add 3 to both sides, or add 4, excuse me. Add 4 to both sides, which is going to give me 3. 3x equals 3. X also equals 1. So that means that my solution for this one is 1, 1. Okay, we're going to talk about these fractions here for a second, because I know that a lot of you might be tempted to look at 20/3 and to do 20 divided by 3 and write that as a decimal. Well, this is a good example. So if I'm gonna do this, and we'll do it in my calculator on here so you can see too. Right, so if I have this calculator, I'm going to do 20 divided by 3. It's going to be 6.6 repeating, and it hasn't a 7, but that's because it just makes the number end at some point. Right, so this is actually the number 6 2/3. So the fraction 2/3 is 0.6 repeating forever and ever and ever and ever and ever. So if you were to write this as 6.67, is that the same thing as 6 2/3? The answer to that is no, it's not the same thing. So the reason why we leave fractions like this is because these fractions are the accurate number. Or that's not a good example, but the 20/3, this is really more so what we're looking at, right? This is the most accurate version of this number because it is precise, it's exact. So we want to make sure that we leave fractions as fractions. All right, a couple of these I'm going to have you do by yourself. think I have one I want to do together. Let's do 4. We'll do this last one together, and then I'll have you do the rest of them on your own. Okay. This one is just kind of lengthy, and it deals with fractions, and I know that people don't like fractions, so we'll try this out. So, another one where getting a variable by itself is not super obvious, right? So, I'm going to pick the first one again because it has subtraction, and so that's pretty easy to work with. So, if I added 8y to both sides, I would have 4x equals 3 plus 8y, right? I'll divide both sides by 4. So x is going to equal 2y plus 3/4. That's my equation solved for x. Now I'm going to take it and plug it into the next one. So we would have 8 times 2y plus 3/4 plus 4y needs to equal 1. Distribute my 8 to both places. So I have 16y plus 8 times 3 is 24. 24 divided by 4 is 6 plus 4y equals 1. Combine what I can combine. 20y plus 6 equals 1. Subtract 6 from both sides. I get 20y equals -5. Divide both sides by 20. I have y equals -1/4. So now I'm going to take that and plug it back into one of my equations. And I think I'm going to use this one. And here's why. This is my thought process behind this. Is my y is -1/4, and if I'm looking at that, well, I have to multiply y by 4. 1/4 times 4 is just 1, right? So I'm going to use the 8 plus 4y equals. So I'm going to do the 8x. This is number 3. 8x plus 4 times -1/4 needs to equal 1. So then we have 8x minus 1 equals 1. So to get rid of this, I'm going to add 1 to both sides. And that's going to give me 8x equals 2. I'll divide both sides by 8. I got to bring it over here. Divide both sides by 8, you get x equals 1/4. Or you would have gotten 2/8, but simplified would be 1/4. So that means that my solution is going to be 1/4 -1/4. Okay? So here's what I want you to do. I want you to go through and solve each of the rest of these on your own. And then when you're finished, you can come back and check to make sure that your solutions are correct with me. So go ahead and pause this now, work on these 3, and then come back to check your answers. All right, so these are what you should have gotten for your answers for the other 3 here. Go ahead and fix whatever it is that you need to fix. But you should have gotten these as your answers. So let's go ahead and look at the last page here quick. So, some real life examples, and this is, I know some of the trickier part of doing equations like this is setting these up, and I know that that's tricky, so we're going to work on these together. So, a theater earns $3,640 from a concert. An orchestra ticket costs 3 times as much as a balcony ticket. 148 orchestra tickets and 76 balcony tickets were sold. We're going to write a system of linear equations that represents the situation to figure out the price of each ticket. Okay, so I know that we sold 148 orchestra tickets. So 148 orchestra tickets times however much money an orchestra ticket is, plus 76 balcony tickets times however much money those are, needs to equal 3,640. Okay, The other piece of information that I'm given is that an orchestra ticket costs 3 times as much as a balcony ticket. So that means X, my orchestra ticket, is going to be 3 times Y. So I'm given my number 1, my first step right here. So my second step is going to be to plug it in. So 148 times 3Y plus 76Y needs to equal 3,640. So if I do 148 times 3, it's going to give me 444Y plus 76Y equals 3,640. Combine these, I get 520Y equals 3,640. Divide both sides by 520. It's going to give me that Y equals 7. So step 3 is I'm going to take my Y equals 7, plug it in. I would plug it into this guy right here. So X needs to equal 3 times 7. X equals 21. So what that means is that the orchestra tickets were $21. Balcony tickets were $7. Okay? This second one then I want you to set up on your own. So there's there's a total of 64 students in a drama club and yearbook club. The drama club has 10 more students than the yearbook club. Write a system of linear equations that represents the situation. So go ahead and set up your 2 equations and then solve to figure out how many students are in each club. Alright, so when you go ahead and set these up, it should have been x plus y equals 64, so however many in each club adds up to 64. But I know that there's 10 more students in the drama club than there are in the yearbook club. So that means that my x plus y, x equals y plus 10 because it has 10 more. So when I solved that, you should have gotten that there were 37 students in the drama club and 27 students in the yearbook club. And that's all for 5.2.